Hello students, let us continue with chapter 8 quadrilaterals. We'll continue with exercise 8.1, the fourth question. So we need to show that the diagonals of a square are equal. 1, they bisect each other. 2, at right angles. So we need to prove three things. That is, for a square ABCD, if you have diagonals AC and BD intersecting at point O, which is given here, you need to prove three things: that the diagonals are equal, that is AC is equal to BD. You need to prove that the diagonals bisect each other. Diagonal bisect each other, that means O is the midpoint of AC, that is OA is equal to OC, and O is also the midpoint of BD, which implies that OB should be equal to OD. So we need to prove this. And then we need to prove that they bisect each other at right angles. That means all the angle made at O, all the angles out here are 90 degrees. So we need to prove what? Angle AOB is equal to angle BOC is equal to angle COD is equal to angle DOA, which is equal to 90 degrees. So let us go about proving each one of these in a sequence. So first of all, I need to first prove that AC is equal to BD. Now we have AC and BD. So we will take two triangles that have AC and BD. I am going to take these two triangles. I will take A, C, D and B, C, B, D, C. So I am going to take these two triangles, prove them congruent, and then by corresponding pair of congruent triangles, I am going to prove that AC is equal to BD. So first of all, I have AD is equal to BC because they are the sides of the square, and you know that in sides of a square you have all the sides equal. This is the common side and each angle is 90 degrees. Why? Because the edges of the square are 90 degrees, that is, each angle of a square is 90 degrees. So let's prove this first. So my first part of my proof, I'll say in triangle ACD and triangle BDC, I have AD is equal to BC, sides of a square. We know that sides of a square are equal. We have angle ADC is equal to angle BCD. Each is 90 degrees. Because we know that the angles of a square are 90 degrees, each angle is 90 degrees, and also DC CD is equal to DC because it's the common side. Therefore, these two triangles are congruent by the side angle side test of congruence. So let us write this. Therefore, triangle ADC is congruent to triangle BDC by SAS test of congruence. Therefore, obviously I can say that AC is equal to BD by corresponding pair of congruent triangles. And we might need this later, so I am going to mark this as statement number 1. So we have proved the first part. Let us see now the second part that we need to prove. I need to prove that OA is equal to OC and OD is equal to OB. So how do we prove that OA is equal to OC and OD is equal to OB? If you consider these two triangles here, AOB and ODC, if you prove these two triangles congruent, then you can prove that OA is equal to OC by corresponding pair of congruent triangles and OB is equal to OD by corresponding pair of congruent triangles. You can even take these two triangles here, AOD and COB. So in order to prove these two triangles congruent, I am going to take these two, you can take these two as well. We need to prove certain tests of congruency in which we need at least one side and two angles. That means we need at least one side and two angles to prove the triangles congruent. Now if you notice, AB is parallel to DC, correct? Therefore, let us draw the triangles first here. ABO and CDO. So getting back to this diagram, AB is parallel to DC. If you see, we have a Z forming here. That means angle ABD is equal to angle CDB. Why? Because they are a pair of alternate angles for parallel lines AB and DC. Again, you have another Z forming here, which means angle BAC is equal to angle DCA, correct? Because again they are pair of alternate angles for parallel lines AB and CD. So let us mark these out here. I have this angle to this angle and this angle equal to this angle. Also, what can I say? AOB is equal to COD. Why? Because they are a pair of vertically opposite angles. Then we can prove that these two triangles are congruent, by which test, or rather we won't take this because it would be angle, angle, angle. We need at least one side. So I am just going to take AB is equal to DC. Why? Because they are the sides of a square. We know that sides of a square are, all the sides of a square are equal. Therefore, these two triangles are congruent, by which test we have angle, side and angle test of congruence. And obviously then we can say that OA is equal to OC and OD is equal to OB, or OB is equal to OD, right? So the second point will be proved. So let's go ahead and prove this requirement. So my second part, I am going to say that AB is parallel to DC and I have BD as the transversal. Therefore, what can I say? That angle ABD is equal to angle CDB. Why? Because they are a pair of alternate angle for parallel lines ABDC and the transversal BD. Now, O lies on the line segment. We are taking which angles? We are taking ABD. So, O lies on the line segment BD. So, instead of writing BO, I will say angle ABO. Instead of taking BD, I am taking ABO because A lies on BD. Similarly, I will say CDO and I will mark this as 1. Now, the second pair of alternate angles is for parallel lines. So, ABCD and we have the transversal AC. So, what am I going to say? Which are my two congruent equal angles? I have BAC is equal to angle DCA. Why? Because they are a pair of alternate interior angles for parallel lines ABCD and the transversal AC. So, again O lies on my line segment AC. Therefore, instead of saying BAC, I am going to say BAO. So, why am I taking BAO instead of BAC? It is because we need to prove these two triangles congruent. And here again I am going to say DCO because again O lies on the line segment AC or CA, and I will mark this as 2. Now, let us go about proving these two triangles congruent and thereby prove that O is the bisector of AC and BD. So, just a dotted line to separate this section from, it is a part of the second section, but here is where your proof starts. So, I will say in triangle ABO and triangle CDO, let us write down our point numbers, let us mark this as 2 because we have 1 there and this as 3. So, we will write down our points number 2 and 3. I have angle ABO is equal to angle CDO and angle BAO is equal to angle DCO, and I will say from 2 and 3. Also, we will show that AB is equal to CD because they are the sides of a square. and AB is equal to CD, sides of a square. Therefore, let's write that triangle ABO is congruent to triangle CDO. Therefore, triangle ABO is congruent to triangle CDO by angle side angle test of congruence. Therefore, let's write down what is required. That is, therefore, OA is equal to OC and OB is equal to OD. Both are through corresponding pair of congruent triangles. And mark this statement as, we have until 3, so let's mark this as 4. You might never know which proof will come into use because when you are left with other things to prove. So always whenever you have any conclusions, just mark them as equations. It's never a harm to mark your equations as 1, 2 and 3 because towards the end you might just be looking throughout your papers where you have proved certain things. Whenever you see some numbers like these, you will know, okay, I have proved it over here and I can easily take reference, right? Now let's go ahead and prove the third part, that is the angles at point O are all are 90 degrees. So let's start with the third part. So I need to prove that angle AOB is equal to angle BOC is equal to angle COD, which is angle equal to angle DOA, which is 90 degrees. So how which triangles are you going to take into consideration? We have seen similar kind of questions while we were solving other problems in quadrilaterals. I am going to take these two triangles ABO and CBO. Let's see why. If you see these two triangles, I have these two sides equal. This is the common side over here, as well as we just proved that OA is equal to OC. Therefore, the two triangles are congruent to each other by the SSS test of congruence. Therefore, I can say that angle COB is equal to angle AOB, but angle COB plus angle AOB is equal to 180 degrees. Can you guess why? Through the linear pair axiom, because AC is a straight line and OB is a line standing on it. But they both are equal. So if instead of COB, if I just take AOB, I can say twice angle AOB is 180 degrees. That means angle AOB is equal to 180 degrees divided by 2, which is 90. Therefore, angle COB is also 90 degrees. Similarly, you can just say that we can prove that these two angles are also 90 degrees. Don't worry, we are going to write it down. So I'll say in triangle AOB and triangle COB, I have, let's take what we have just proved, OA is equal to OC, and I'll say from 4. Then I have AB is equal to CB. Why? Because they are the sides of the square. We know that in a square all the sides are equal, and also what is common? We have OB is equal to OB because it's the common side. Therefore, triangle AOB is congruent to triangle COB by the SSS test of congruence. See, we have all the sides equal. Therefore, side test of congruence. Therefore, let's write down. Therefore, angle BOA is equal to angle BOC. Why? Corresponding pair of congruent triangles. Let's mark this as 5. Now, I have, but angle BOA angle BOC is equal to 180 degrees through linear pair axiom. So from 4 and let's mark this as 6. So from 5 and 6, let's substitute for BOA as BOC. So I'll say therefore angle BOC plus angle BOC is equal to 180 degrees, and I'm going to say from 5 and 6. So apple plus apple, 2 apples. So BOC plus BOC is 2 BOC, 2 angle BOC, which is 180 degrees. Let's get down 2 over here on the right hand side to divide 180 degrees, which would be equal to 90 degrees. So now, therefore, angle BOC is equal to 90 degrees, which is also equal to angle BOA, and I'll say from 5. Correct? So we have proved 2 of the angles as 90 degrees. I can say similarly we can prove that angle angle COD is equal to angle DOA, which is equal to 90 degrees. We can prove that angle COD is equal to angle DOA. Let's mark this statement as 6. DOA is equal to 90 degrees. So to prove these 2 angles as 90 degrees, you're going to take which 2 triangles? You're going to take triangles COD and AOD. Right? So you can say from 6 and 7, angle AOB is equal to angle BOC is equal to angle COD, which is equal to angle DOA, which is equal to 90 degrees. So we have proved all what is required. So the first part is proved here, the second part is here, and the third part is here. The second part stretches a little bit until here. So our board is full. We do not have much space. So let's continue with the next sum in the next class. Thank you.
Hope this video increased your knowledge. For more such videos and a completely free educational content, log on to www.epathshala.org or visit our ePathshala YouTube channel. We have each and every question solved for maths, physics, chemistry and biology. So subscribe our channel, share with your friends, like our Facebook page and follow our Twitter handle for regular updates and important educational tips, and also win ePathshala goodies. So what are you waiting for? Subscribe this channel and enjoy the freedom of education.